Today's United States Navy is a balanced defense team designed to meet any counterinsurgency, contingency, or war requirement. As a vital part of this team, I'm called upon to project our country's image and protect her policies and interests. The Seabees, whose name is derived from the initial letters of the words Construction Battalion, have advanced and added to the colorful traditions which began with their formation in March of 1942. Since that time, their motto has been, "Can do." The modern construction battalions live up to that motto. They can do anything. They do not know the meaning of the word impossible. Today's Seabees are members of the Navy's Special Combat Support Forces, and as such, contribute to our national policy of world leadership. This is evidenced by the deterrent role the Seabees are playing in defense of the free world's position, as well as their potential as catalysts in successfully conducting military and economic assistance projects overseas. They're highly mobile, self-reliant, confident, and efficient. A force in being ready to provide engineering and construction support, coupled with disaster recovery capabilities to all the armed forces, government agencies, and nations of the free world. First and foremost, Seabees are military engineers and builders, highly trained in engineering skills, all construction trades, and able to perform under the most trying conditions. Men, material, and equipment are combined to handle tough jobs anywhere. During Cold War times, the Seabees have a dual mission: military readiness and military engineering and construction. They must at all times retain the capability to rebuild what has been destroyed. To best perform their mission, the officers and enlisted personnel are organized into fleet units totaling 12 construction battalions, 6 operating in the Atlantic and 6 in the Pacific. To ensure that each construction battalion can be self-sustaining, its complement includes many other U.S. Navy rates, in addition to the Group 8 or construction rates. The entire active fleet naval construction force totals 250 officers and 6,000 enlisted men. The organic material and equipment allowances for these battalions are kept modern through a continuing review process and a dynamic research, development, test, and evaluation program. This ensures battalion ability to respond and conduct operations within the time frame required of the balanced Navy and Marine Corps combat team. Normal organic equipment allowances can be augmented, usually by commercial automotive equipment assigned on a day-to-day basis for large construction programs. There are also supplemental functional components, such as this rock crushing plant, or this asphalt plant that can be assigned to meet certain contingency plans. The Naval Construction Forces are divided into 2 amphibious construction battalions, or ACBs, and 10 mobile construction battalions, or MCBs. These fleet units are commanded by officers of the Civil Engineer Corps. The amphibious construction battalions are specialized units which provide the vital link from the amphibious assault ships to the beach in the form of causeway piers, ship-to-shore bulk fuel lines, and limited construction capabilities. Each ACB consists of approximately 31 officers and 638 enlisted men, all expertly trained in the specialized and technical skills required for amphibious landings and related construction work. The organic equipment allowance for each of the amphibious battalions is worth over $9 million. The mobile construction battalions are, as their name implies, highly mobile and equipped to construct and defend any facility, anywhere. Each battalion is composed of approximately 21 officers and 563 enlisted men, whose skills and knowledge, gained from training and experience, enable them to handle all construction jobs required of them. The organic equipment allowance for each Mobile battalion has an inventory value of over $3 million. Behind these capabilities is a broad program of training in construction, military tactics, and specialized skills. Primarily, all Seabees are initially trained and schooled at Port Hueneme, California, at the Naval School's construction, where the potential of selected men is developed. These men are given elementary through advanced training in the 7 basic construction ratings: builder, construction mechanic, construction electrician, equipment operator, steel worker, utilities man, and engineering aide. Naval Construction Forces' Cold War operations require continual review and improvement of techniques. The critical path method for construction scheduling is one of the many modern streamlined techniques that are used and taught in Seabee classrooms. Seabees must be able to defend what they build. They learn the latest military tactics from top-grade Marine-trained instructors at sites on both the Atlantic and Pacific coasts, where actual wartime conditions may be simulated. Each battalion has its own team, which is trained in all phases of disaster recovery, including requirements for nuclear, biological, and chemical warfare. These teams learn rescue methods, how to determine, chart, and report the extent of contamination, as well as decontamination procedures. Naval construction forces are constantly deployed worldwide. Whenever possible, this deployment is within areas where existing contingency plan require Seabee capabilities and where construction work, training programs, environmental conditions, and defense problems will add to battalion experience, operational readiness, and ability to respond. The amphibious construction battalions are continually deployed with the fleets in the Mediterranean, Caribbean, and Western Pacific. As part of their program to maintain operational readiness, the battalions frequently hold amphibious landing exercises, improving their ability to provide facilities for 6 widely separated beaches. Each beach is assigned one of the ACB's causeway piers, normally 4 to 10 sections long. After these sections have been launched from the transporting LST, they're moved into alignment by a Seabee warping tug and 2 of their causeway tender craft. Seabees join the sections, and the completed pier is brought to shore. As it grounds on the beach, 2 tractor operators pass winch cables to the pier to secure its inshore end. Warping tugs and causeway tender craft place anchors to hold the pier in place. The LST then moves into position. Its ramp is married to the offshore end of the pier, and cargo is discharged. Seabees provide 4 transfer lighterage barges made up of pontoons and powered by a propulsion unit for each beach. These barges transfer supplies ashore from the ships of the task force. The ACBs also provide each beach with 1 or 2 ship-to-shore pipeline fuel systems, either buoyant or, as here, bottom-laid. Within a few hours after the initial shore landing, these pipelines are pulled 5,000 feet to sea, ready to pump ashore approximately 600 gallons of fuel per minute for the amphibious assault forces. Each beach has a salvage capability, usually consisting of 2 size 5 tractors, 1 surf crane, and accessory equipment. The Seabee salvage teams keep the boat lanes and beaches clear for the material and supplies coming over the beach by refloating broached landing craft and bringing to shore for repair the disabled craft. Both amphibious construction battalions have a limited construction capability, which includes the building of helicopter landing fields and other assault beach construction such as fortifications. Through continuing research programs, the ACBs are helping to develop new techniques to make their ship-to-shore operations faster and less hazardous. The ACBs assisted in the operational evaluation of the View ship's developed Highline Cargo Transfer System, a means by which cargo is carried over a pre-tensioned highline wire from a sea terminal to a terminal on shore. Here, a modified LCU serves as the offshore platform. A 70-foot high tower, hydraulically erected, supports the sea end of the system. A modified LVT, transported to the landing area by LST or similar means, swims ashore and positions itself as the shore terminal. Using an A-frame to gain necessary height, contact is established and the highline rig is secured. With two highlines operating simultaneously from one offshore platform, average delivery rate becomes 40 tons per hour. As a means of extending the efficiency of the transfer system, an LST, after discharging its cargo of rolling stock, can be reloaded from an AKA, beached, and used as a sea terminal. Newly developed ACB equipment includes inflatable causeway pier sections. Designed for transport in a deflated state, they double the pier carrying capacity of each LST. Automatic power pipe tongs, now a standard part of the 6-inch fuel line system, properly align and thread together pipe sections and greatly reduce the time and manpower formerly required to install the ship-to-shore system and commence pumping waterborne fuel to the Amphibious Assault Bulk Fuel System depot on shore. As a part of their primary mission, ACBs may be called upon to provide disaster relief and conduct disaster recovery operations on a beachhead. This capability was used in Haiti when the flooding of Lake Miraguan severed east-west lines of communication and completely destroyed the bridge, preventing shipment to Port-au-Prince of vital agricultural produce from western Haiti. As a result of the personal request of the U.S. ambassador to Haiti, ACBs were brought in, and within a month, facilities were restored. The Mobile construction battalions are military construction teams, equipped and ready to move across the beach and over land to design, build, and maintain required facilities, such as earth fortifications, roads, buildings, fuel tanks, and communication systems. To do this, they have developed a tactical organic table of allowance consisting of approximately 248 pieces of automotive and construction equipment. As they must be capable of defending their construction sites against enemy offensive movements, they are outfitted with the most modern firepower. This includes 106mm recoilless rifles, 81mm mortars, 3.5-inch rocket launchers, and the new 7.62 caliber NATO weaponry. But construction is the primary mission of the Mobile Construction Battalions, and to maintain and improve their construction capabilities, the MCBs are deployed on a worldwide basis, constructing large fleet support facilities, ranging from housing at Guantanamo Bay to permanent airfield and warehouse facilities for the Marine Corps on Okinawa. An important new MCB mission is building the portable small airfield for tactical support, developed by the United States Marine Corps. A launch and arrest mechanism, which reduces the length of landing surface required, enables these airfields to handle high-performance jet aircraft. New Seabee installation and operational techniques will make it possible for one of these airfields to be operational within 72 hours. Continued and intensive MCB research, carried on in the same manner as ACB research, has resulted in new and more specialized construction methods, equipment, programming, and development. The bomb damage testing program is an example of MCB research and development. This program involves the search, through actual construction experiments, for newer, faster, and better methods to repair, rebuild, restore, and strengthen bombed-out sections of existing airfields. Equipment must be adapted and redesigned to meet the many and varied new requirements of MCB capability expansion. Mobile construction battalions must maintain their military operational readiness. The tactical and disaster recovery training each man receives for approximately 2 months of every year is integrated with experience gained under actual operating conditions. 2 Mobile construction battalions were deployed to Guantanamo Bay, Cuba in the fall of 1962. They constructed and completed hardened fortifications on an accelerated schedule to immediately improve the defense system of the naval base. 1 battalion ceased construction and for 5 days manned defense positions until relieved by Fleet Marines. MCB military engineering capability and readiness extends into other areas. The construction of Project Mercury tracking stations for the National Aeronautics and Space Administration on Canton Island in the Southwest Pacific. Construction work to support nuclear testing operations at the Nevada test site and on Christmas Island. Assembly of a nuclear reactor power plant at McMurdo Sound in the Antarctic. To provide docking facilities for Polaris submarines at Holy Loch, Scotland, Seabees erected this 70,000-ton capacity floating dry dock well within the time frame specified. In Greece, a vital communications link was needed to ensure essential strategic operational capabilities. The Seabees met the fleet occupancy date. In Southeast Asia, there was immediate need for an operational facility to be constructed at Udorn. Again, the Seabees did the job. An airstrip in Thailand, built under the Military Assistance Program of the United States Air Force, was required to be operational within a 6-month time period. The Seabees had it ready in 5.5. Mobile construction battalions represent a rather unique disaster relief capability within the United States Navy. Where nature destroys, the Seabees build. In Haiti, a hurricane severely damaged the deep draft pier at Port-au-Prince. It was rebuilt within 6 months by Seabees, who in addition trained Haitian people to operate and maintain construction and automotive equipment. In Guam, as a result of a devastating typhoon, emergency disaster recovery techniques and a long-range rehabilitation program were required. The Seabees met both requirements. Within our own country, when a crippling earthquake hit Alaska in March of 1964, Seabees were flown from their base in Port Hueneme within 24 hours. They used their experience and skills to repair and restore the naval station at Kodiak and to assist in emergency operations within the city itself. To more effectively participate in and to more efficiently prosecute their goals in the counterinsurgency program of the United States, there have been developed within the Naval Construction Forces several Seabee technical assistance teams. These Seabee teams are a highly trained nucleus composed of 1 Civil Engineer Corps officer and 12 to 15 enlisted men. Their basic mission is to furnish technical assistance, to construct, to train, and to help. To meet this mission, the team must be responsive and fitted for airlift. Their main contribution has been in the field of socio-economic, civic action, people-to-people, and training programs, working with civilian and military personnel of the less developed and emerging nations of the world, training them to develop their own skills and capabilities. All Group 8 ratings are represented in each team. Every man is given inter-rate training in addition to his own specialty, thus producing a broad construction capability within a small nucleus of personnel. Team members receive intensive training on every aspect of counterinsurgency, language, country familiarization, military, as well as communications, demolition, guerrilla, counter-guerrilla, escape, survival, and underwater operations. Each team is trained for a deployment in a specific country and learns that country's customs and traditions. Equipment allowance for each Seabee team consists of 14 pieces of equipment worth approximately $150,000. The entire allowance for one team can be carried by a C-130 type aircraft. Seabee teams are and have been deployed in many areas of the world. In Chile, an earthquake partly demolished the naval shipyard at Talcahuano. A Seabee team repaired it and at the same time trained the host country people to construct, maintain, and operate equipment on their own. In Thailand and South Vietnam, well drilling, irrigation, and dam construction projects were accomplished by these teams as they trained the local populace to build facilities and operate construction equipment themselves. In the Dominican Republic, another team initiated a more formal training program. At a manpower development training center, Dominican people learned to use and repair construction, maintenance, and power equipment. This type program is intended to provide a country and its people with a capability comparable to more developed world areas. This Seabee program is successful. The aim of all Seabee teams is the same as for all members of the Naval Construction Forces: to help the other fellow get his job done. An accurate measure of the value of a Seabee team service is summed up in this statement by a U.S. ambassador to a country in an area subjected to direct communist pressure.
The dispatch of a single Seabee team was most effective in discouraging whatever latent communism existed in that area.
In addition to contributing to the social and economic assistance of other countries through the formal Civic Action Program, the Seabees are making friends on their normal deployments wherever they may be. In their off-duty hours, they build and sponsor such people-to-people programs as hospitals, orphanages, and playgrounds. For example, on Okinawa, they built this fire station and equipped it with a Seabee-designed fire engine. To augment and back up the active construction battalions, Seabee reserve officers and enlisted men are pre-trained and pre-organized into ready reserve battalions, which train annually as units to increase organizational and individual proficiency. The only reason for a military organization of any kind is to meet the requirements of war, whether it be all-out war, a limited war, contingency operations, or counterinsurgency activities. The Naval Construction Forces are prepared and ready to handle any emergency within that framework. They are equal to the most demanding requirements. But unlike the majority of military units, they are not a destructive force. Instead, they are a constructive and recuperative one. Perhaps of even greater significance is their aggressive participation in combating the insurgent activities being conducted against the free world. The Seabees are a force in being. The past found that they could do. The present finds that they are doing. And the future will find that the Seabees can do.